Welcome back, everybody. In this video, we're going to be going through some meanings for division and calculating or figuring out what it is that division tells you when you do a division. And then we'll see how to do division with fractions and look at a couple of examples. So where we want to start is by looking at some meanings for division. That is, what does division tell you? And this part is true for division kind of just with numbers in general, not just fractions. What division tells you is if you have an amount of something, people or pages in a book or pounds of cookie dough or whatever it is, and you put it into groups of equal size, and that's important. If you put it into groups of equal size, division can tell you one of two things. It can tell you either how many groups there are, or how many piles of cookie dough there are, or whatever it is, how many groups there are, or how big each group is. As an example, or two examples, suppose that you have 80 quarters. Okay, there's a big pile of quarters. It takes 10 quarters to do a load of laundry. How many loads can you do? So in this case, you have this big pile of 80 quarters, and you're putting it into groups of a known size, that is 10 quarters, and you want to know how many groups you can get out of it. Of course, an essential assumption in this is that it's the same amount of quarters for every load. If you didn't know how many quarters it took to make a load of laundry, some more, some less, then there'd be no way to answer this question. That's why the part about being groups of equal size is important. Okay, next example. Suppose that you have to deliver 400 pounds of gravel with your truck, and you know you can do it in 2 loads. How many pounds of gravel would end up being in each load? In this case, you have this whole amount, 400 pounds, and you're putting it into a known number of groups, and you want to know how big each group is, or each pile of gravel in this case. So you have a whole amount of something, and you're putting it into chunks or groups of equal size, and you want to know either how many groups there are or how big each group is. That's division. Okay, so now we want to start working towards thinking about fractions. And so sticking with whole numbers for a minute, we want to ensure that we can think of division for whole numbers first. So we all know that 12 divided by 3 is equal to 4, and we have several ways of thinking about how that is. One is if you have 12 dots, as I'm drawing out here, and we put them into 3 rows, there will be 4 dots in each row. That's a way of thinking about it. Of course, if I had drawn the picture the other way around, we still would have 12 dots, and we could say, okay, well, now we're putting 12 into 3 groups, each of which has size 4, or we could say that we're putting 12 into groups of size 3, and we have 4 such groups. Okay, another way to think about it is if we take 12 and we subtract 3 from it, 12 minus 3 is 9, 9 minus 3 is 6, 6 minus 3 is 3, and 3 minus 3 is 0. How many times was I able to subtract 3 from 12? There's 1, 2, 3, 4 times I was able to subtract 3 from 12. So it kind of answers the question, how many 3s are in 12? And the answer there is 4. Okay, there are 4 3s in 12. All right, so now we want to try to transfer some of this thinking into fractions. So let's, sure got everything off of here, yes. All right, so for this next part, I want to illustrate some of these things with pictures, and I want you to kind of think about how we thought of 12 divided by 3 equal to 4, and how a way of thinking about it was how many 3s there are in 12, and we saw that there were 4 3s in 12. So for this first one now here on the left, I have 1/2 divided by 3/4. We want to figure out how many 3/4 there are in 1/2. So let me draw a picture. And I'm going to put it into quarters because the problem involves halves and quarters. And so let me look at 1/2. How big is a half in here? Okay, so the whole big rectangle was 1. So the part that is coming out shaded now is our half. And so we want to think about how much of a 3/4 is there. So let me draw what a 3/4 looks like. So a 3/4 would be 3 of these blocks, right? So let's do that with you. All right, that's 3/4. The whole was divided into 4 parts, out of which we shaded 3. So this is 3/4. So how much of a 3/4 is shaded here in blue? Well, the 3/4 consists of 3 of these blocks. There are 2 blocks that are shaded in the upper picture. So the answer finally is 2/3. There are 2/3 of a 3/4 in 1/2. Okay, so take a minute to think about that before we try the next one. All right, so let's try that again. This time we want to know how many 1/2s there are in 3/4. So let me draw out 3/4. If you don't like all the pictures, it's okay. We're going to very soon have a way of doing this without doing all the pictures, okay? All right, so here's one whole. Let me look at 3/4. So here's 3/4. We want to know how many halves there are in 3/4. Okay, the whole rectangle that we divided into 4 parts was our one whole. And so 2 of those blocks make up a half, right? So how many halves are there in this 3/4? Well, the first 2 blocks make 1 of those halves. And then we have one more half of one of those halves. So there are 3 halves in our 3/4. Okay. The next 2 will be simpler. All right, so now we want to see here in 2 how many 1/3 there are in 2. So let me draw 2 whole units, 2 whole candy bars or pizzas or whatever, and we want to know how many 1/3 there are. Okay, so if I take 2 and put them each into thirds, there are going to be 6 of those thirds. There are 6 1/3 in 2. Okay, now before I do the next one, I want you to think about how many 1/2s there will be in 4. So this is going to take a little time. I need to draw out 4 holes, and they're going to be in halves. How many halves are there? Well, if there's 4 holes and each one is going to give us 2 halves, 4 times 2 gives 8. There are 8 halves in 4. Okay. So now this one, I want to see if we can detect a pattern and see if we can avoid drawing the picture for this one. So in the first one, we had 2 divided by 1/3. We saw that that was 6 because each of those holes was divided into 3 parts. 2 times 3 gave 6. Here we have, in the second one, we had 4 holes and we've divided each one into halves. There's 2 halves to make a whole. 2 times 4 gave 8. So now for this next one, 5 divided by 1/4, we want to know how many 1/4 are in 5. So let's just pretend for a moment that I actually did draw the picture. If I drew the picture, I would be drawing out 5 rectangles. 1, 2, 3, 4, 5. I would draw out 5 rectangles, and each one would be divided into 4 quarters. So if I had 5 divided into 4 parts, how many of those little parts would there be? There's 20. Okay, hopefully you said 20. There are 20 of those quarters in 5. All right, let's try this next one. This one, because the numerator is not a 1, it's going to be a little trickier. So I will actually draw the picture on this one. So let me draw 3 whole units. And we're going to figure out how many 3/4 there are. Okay, so there's 3 whole units. I've divided each one into quarters. So now I want to know how many 3/4 there are in this. 3/4 would be 3 of those little blocks. I want to know how many of those there are in my 3. Okay, so let's start figuring that out. So here's 1. Okay, there's 1. 2. 3. And notice that in each of these holes, there's 1 little block left. So that's going to make up a 4th one. Just decide on a color for that. There's 4 of those 3/4 is in here. Okay. All right. So now I understand you probably don't like the pictures, and that's okay. You don't have to do this using the pictures, even if you do understand it, because we're going to have a way of doing this more realistically here in a second. But I did want to point out what this pattern is, the pattern that these pictures are giving us. So let's take a look at that. So here, when we had 2 divided by 1/3, we ended up calculating 2 times 3/1, giving it 6. And 4 divided by 1/2 is the same as 4 times 2/1. That gave us 8. And then 5 divided by 1/4 turned out to be the same as 5 times 4/1. And even in this next one, 3 divided by 3/4, we ended up calculating 3 times 4/3. So we ended up kind of trading the 3/4 with a 4/3 and turning it into a multiplication, and that's what it's that for. So it's going to turn out that we're going to base our method of calculating fraction division on that observation. So that's coming now. All right, so one of the uses we have for variables, that is a letter to represent a number, is to show a pattern. And that's what I'm doing here when I say let A, B, C, and D represent numbers. So they're going to stand for any numbers you want, because we're trying to develop a general rule. And we do have a restriction on this one that B, C, and D are not 0. As you know, we can't divide by 0, so that's a restriction we are making. So we're going to try to make up a rule once and for all. So A over B is our first fraction, and we're dividing by another fraction, C over D. And we know that B, C, and D are not 0. So let's divide these 2 fractions according to the rules we know so far. Okay, so this is one way of writing division, as you know. And then another way of writing division is by stacking the 2 numbers you're dividing, one on top of the other, right? You know that if we were to write 20 divided by 4, we could just as well write 20 on top of 4 like that, right? That's all I've done right here. Okay, and then based on what we saw here about multiplying, turning our division into a multiplication, and we traded 1/4 for 4/1 and 3/4 for 4/3. We kind of flipped over those fractions. We'll go into more detail about that shortly. Based on that observation, we're going to use the fundamental property of fractions here, and we're going to multiply the numerator and denominator of this fraction, according to the fundamental property. We're going to multiply by D over C. And our reason for choosing D over C is based on what you saw on the last slide, how we ended up turning our 3/4 into 4/3 and so on. Okay, so now, according to the fundamental property of fractions, you can multiply the top and bottom of a fraction by the same thing. So then we'll have down below C over D times D over C. And up top, we'll have A over B times D over C. All right, so then down below, you can see that we have CD, C over D, times D over C, and then we can use the fundamental property of fractions just down here and simplify out that common factor of C as well as the common factor of D. And all that's left in this whole denominator then is a 1. And up top, we'll have A over B times D over C. Okay, so then, if you like, you can skip all this stuff in the middle, and we're going to end up with A over B divided by C over D ends up being the same as A over B times D over C. Okay, and how we got there, we used the fundamental property of fractions. We used the fundamental property of fractions again to simplify that denominator. And then we know any number divided by 1 is just going to be that number. So we followed the rules. And so we've seen that we can replace a division of one fraction by another with a multiplication. Instead of dividing by C over D, we can multiply by D over C. All right, so that's how that works. If you don't like to use the pictures, that's totally okay. I use the pictures because I like them for some things, and I wanted to kind of make this not so surprising. And but you can just use this, take it as a definition if you didn't like anything about the pictures. Okay, so then the next thing we do, or we'll need to do, is we'll have a little bit of terminology for this D over C thing, and then we'll see some examples.